Welcome to Let's Get to the Marks. Here are some chemistry practice questions for your A level. These are to supplement those exam questions you've been doing on Physics and Maths Tutor, Save My Exams, and various other websites like the AQA, OCR, or Edexcel website. Okay, let's get into it. So, question one, give the electronic configuration of the following atoms and ions. We've got aluminium, silicon, sodium ions, aluminium 3 plus ions, nitride ions, Mn2 plus ions, Sc3 plus and Se2 minus ions. Question two, draw the full electronic configuration using the box notation for fluorine and neon. Identify the element with the fourth shell configuration 4s2, 4p2. C. Suggest the identity of an atom, a positive ion, and a negative ion with the following electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6. Why don't you grab some paper, pause the video, have a go at this, then unpause and watch the answers. Okay, so for question one, give the electronic configuration of the following atoms and ions. So aluminium is 1s2, 2s2, 2p6, 3s2, 3p1. It's got 13 electrons, so just fill it out as you go. Silicon has 14 electrons, so 1s2, 2s2, 2p6, 3s2, 3p2, so one more than aluminium. And then C, a sodium ion. Sodium atoms have 11 electrons, so 1s2, 2s2, 2p6, 3s1. However, it's lost an electron because it's a positive ion, so its outer shell has 2p6. Aluminium 3 plus, normally 13 electrons, but has lost 3, so down to 10, has the exact same electronic configuration as a sodium ion. And the nitride ion, N3 minus, 1s2, 2s2, 2p6. Notice how all three of these have different charges, but have all ended up with the same electronic configuration. And for F, we got the manganese 2 plus ion, we got 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. You can see that because the ion of manganese has a partially filled 3d subshell, this makes it a transition metal. And for G, Sc3 plus, you can see that when it becomes an ion, it doesn't have a partially filled 3D subshell. So although it's on the same row, it is not a transition metal. And then the final one, we have H, which is a selenium atom that's gained 2 electrons, so interestingly is called the selenide ion, has a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6 electronic configuration. And that's the end of question one. So now we're looking at question two. Draw the full electronic configuration using the box notation for fluorine and neon. So you need to put arrows in these boxes like so. Of course, you draw the arrows in different directions. That's because of opposite spin pairing. They spin in opposite directions to reduce repulsion between the electrons in the same orbital. Also, make sure you fill the orbitals one at a time. It's greater stability that way. Of course, what makes fluorine so reactive is that it's one short of having a full 2p6 second level complete shell, whereas neon completely unreactive just because it has one extra electron and has the full second quantum level filled with electrons. Okay, for question 2b, identify the element with the fourth shell configuration of 4s2, 2p2. And the answer there is germanium, which you will find in the P block because it has a partially filled 4p subshell or p orbital. Now, for C, suggest the identity of an atom, a positive ion and negative ion with the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Obviously, that's 18 electrons. There's only one element in the periodic table that can, in its atomic form, have that configuration, and that is argon. So Ar has that exact electronic configuration with 18 electrons. But of course, there's many different negative ions and positive ions that can also adopt that electronic configuration, because after all atoms are interested in having the noble gas configuration. And so we can have different ones like potassium plus. Obviously, potassium has 19 electrons. So when it loses an electron and becomes a potassium positive ion, it becomes and has the argon electronic configuration. A chlorine atom has 17 electrons, one away from that argon noble gas configuration, so gains an electron to become a chloride ion and ends up with that configuration. Some other ones that also positive and negative ions that end up with that configuration. You've got the calcium ion, you've got the sulfide ion, and the phosphide ion. Absolutely wonderful. Like, share, subscribe, help big up the channel, please. Massive respect. And yeah, more of these videos coming and more exam walkthroughs to help you smash A-level chemistry. Let's go.
You're still here? It's over.